microscope. It's basically it's a class of it's in a class of microscopes that are generally called scanning probe microscopes. They cost about 10 grand or so to make. But you can make one for far less if you have the right a little bit of knowledge and the right kind of stupidity. So what I was going to attempt today was actually to test this thing out. So I've got this little scanning head, and what I was going to try to do was shine a laser at it, and there's a mirror on there, and I was going to try to see how much the scanning head moved by looking across the room where the laser light's shining and be able to measure that. And that should work. Just that right now it's not working right now, so I failed. So that was a cool little blinding people with science attempt. But so now I don't really have much to talk about. Unless someone wants to ask me questions about the microscope I'm building. Sure. I figured the business of that.
What do you plan on imaging?
Right now, my background is chemical engineering, so I'm really interested in imaging nanoparticles. I'm working. I actually have nanoparticles. I just realized that I don't know how small they are, so I can actually image them.
Yeah.
Sure.
What is the visual? What is the display that you look at?
An STM will give you an actual three-dimensional image. What this is giving me, I'm taking this through an Arduino, and so it's actually giving me XYZ coordinates of the surface. So the basic theory of this works. So you have a point, it travels over the surface, a needle travels over the surface, and it's giving you the Z coordinates of wherever you are on that surface. So you put that into Excel and do 3D plotting. So I really wanted to give me tips in this direction.
Is it a physical needle?
It's a physical needle.
How do you create, get?
So what you do, you have to get a comically sharp needle. In this case, we usually take a tungsten and you electrochemically etch it. You stick a needle of tungsten into a bath of very strong sodium hydroxide, so Y, and you put about 20 volts across that and let it sit there and etch for a while, and then eventually the needle tip will break off, and at that point, what's left is a comically sharp. Or very close to comically sharp.
My background is in geographic information systems, and you stuff to do with laser or anything, lighting stuff, and it's all XYZ coordinates, because that can visualize in 3D and export to I got software.
Oh, that'd be interesting.
Of course, ours is much larger scale, but I mean, it's just a matter of...
No idea. Right now, I just have a Python script just spitting out a common separated value list of points. And I'd like to turn that into text. Because the reason why is because there's an open source STM image manipulation program that takes TIFF files natively. TIFF files you can use and take Adobe and use it. That's why. We'll go with that. Yes, John?
How do you move the needle?
How do you move the needle? Alright, so that's actually what this whole thing is. So traditionally, STMs use three different piezo discs. And there are three different piezo tubes, and those cost about $300 a piece, so it's $900 to get X, Y, and Z. In this case, I'm actually using a single unomorph piezo disc cut into quarters. A unomorph piezo disc is also known as a piezo buzzer. They cost about $2 a piece. You cut into quarters, and so now you have 4 contacts on the surface, and by putting voltage into those 4 contacts, you can actually buckle the disc a little bit, and that gives you X and Y motion. And then by using the ground, the voltage bias, it gives you Z motion as well. So that if I draw it on a board, I don't have anything to draw on. Yay!
4, 3, 2, 1.
How's that? That's a question.
And that F is an STM.
There we go. That's how it works.
Nice!
So this is it. It moves like that, and I'm out of time, so I'm done.